Tamást szeretném nektek bemutatni. Ő fogja tartani a következő előadást. Tamás olyan élvezettel épít.
So the next presentation, now Tamas is actually someone who loves to build networks, and he loves everything that has IP address and flies, and if the whole thing goes together, then he's really delighted. So Tamas, the floor is yours. Thank you very much. Actually, let me introduce myself again. My name is Tamas Szekely. I'm going to talk about the first hop redundancies, and I'm going to talk about the two protocols, the URP and the HubSub. Now, there are going to be very nice pictures in the beginning as an introduction with some light pictures, and then we are going to talk about Wireshark and RFC realities, so let's get started. The first slide is about how an average user views the network. Well, it's not a detailed view. You just have an RI45 connector that you see. They don't know that this is an RI45 connector, so they just call it a plug. And then you see a chaotic maze. And if he does well, then he can access the resources needed for the work, but the best resources are of course banned, because this is why there is a firewall, so that he would not see the Facebook and the YouTube. This is only for the managers. Now, his view on network redundancy is just minimal. Let's go to the system administration view, system admin's view. Now here there is a beautiful system view. You can see the domains, and you can see the different user groups and sites and subnets to those sites. And I think that the system administrators, the sysadmins, think that the network is a necessary evil. It is just complicating their lives, because they need to push everything to the soldiers of the network administrators. I don't want to kick them very much, because this is probably true from the other side as well. Anyway, in an optimum case, we cannot talk about network redundancy, and this is not the most important part of their interest. If we look at the network diagram, then you can see that there is redundancy. This is just a recommendation, and there is a layer 2. On layer 2 they are wired, but there is also layer 3 redundancy. This is what we can see. There are the protocols here, and in the lower layer you need to find out something else, because it would be difficult to have dynamic routing protocols there. And it is here where the two protocols are going to be used that I'm going to show you. Now, the layer 2 implementation, how this looks like physically, this is another issue. What I wanted to tell you with this short introduction is that there is redundancy, or at least you ought to have and supposed to have, and bigger companies do have it. And the other important thing is that this is not really visible. A colleague of mine said that the good IT person is invisible, because he's not there, you don't need to look for him, and he's just concealed. So there is redundancy, but why exactly we are attacking the redundancy? Because we are going to use very complicated processes. Why are we doing this? Now, this picture, I'd like to show you the difference. This is RP poisoning. RP poisoning is big, robust, you can see it from kilometers, and it sends the packages or the bombs. So the two things are destructive, identically destructive. And it's easy to protect yourself, because you can early warn, you can see it from a distance, and it has a lot of, there's a lack of precision. And I think this is what the companies are protecting themselves against most. The HSRP, however, on the other side, is much different. It is much more, it could be deadly, very deadly, and it could be very easily done. And you can also get into the middle So this is one of the most important objectives of the presentation. Now, what is the objective of the presentation? I would like to show you some easy tools. We are just going to see what buttons you need to press. We go under the hood as well to see why this works, and then we're also going to see different devices, and both to achieve objectives, and this is what these simple tools are going to help with a live demo. Let's start with the HSRP protocol. The HSRP, this was determined by Cisco in 1998, Cisco proprietary, March 1998, make the definitive gateway fault tolerance so that there would be a layer 3 redundancy. And what they did, they took 2 or more devices, they put it into a group with a virtual IP address and a standardized MAC address, and as a default gateway, this virtual IP address is given to the host. Now this is what they are going to use all the time, despite the fact that these devices in the background will decide which of them is going to answer the IP call. It's always the higher priority device that is going to respond to the virtual IP address. If there are 2 identical priorities, then the one with the higher IP address will take it over. Now this is the MAC address. This is important. We're going to use it, and the reason we are having the table tennis table tennis table is because this is both the active and the passive devices are serving. In 3 seconds, every 3 seconds you need to serve, and then if you stay out for 3 serves, then you're out. So this is the most important point here. You can of course adjust the time 10 seconds or subsequent level, and you can have a very fast protocol as a result of that. We are not going to go into the package. We are going to talk about the version number 1, which is the more widespread. Version 2 has not a lot of novelties. Instead of 255, there are 496 standby groups that it allows to create, and also the multicast address was changed. I think that now it's instead of 12, it is 102 or 12. Now the operation code is going to be important. We can have 3 different types, and in default there are going to be hello packages going back and forth. This is the service, this is the serving. One is the COOP message. The COOP message is sent by the host to the other if he would like to become the active device because he thinks that his priority is higher, or because he's the attacker. Now, resign message is sent by the active device if they want to resign from their active status. The active and the standby status is now determined. Now, you're in speak status if the device just discusses what its role should be, and all the other devices are in listen. So those that are not active and or standby, they are all in listen mode. And let's start the demo. And the objective of the demo is going to be to serve the attack descriptions. So we want to make a man in the middle with these attack descriptions that you can find on the internet quite extensively. This is what our network looks like. This is what I brought together from the devices that we can see here. This is ourselves. We have 2 switches. We have 2 routers which are serving. There's the HSRP here. Our virtual IP address is going to be 3, and we have a test router which from where we want to reach the destination, and we will see what happens to the router, and we will see what we can do in order to get the packages first to come here and then go to the destination, and vice versa. In order not to have to type so much, I wrote a script, so I'm just going to press the enter and I'll tell you what the script does. Now we are in the test router, and we ping the destination. There is some ARP, some thinking, but basically the exclamation marks mean that there was a response. And then when we started the script, it just brings up an interface and launched a capture there. This is what we can see here in the background. You can see that the packages are going back and forth, coming from IP address 1. The priority of that router is 110, and the priority of the second router is 100. What matters is that we have authentication data, but basically the HSRP authentication can be three types. Either there is no authentication, option 1. Second, there is authentication simple text, in simple text. Then you will just see what was written there as a configuration. And there is an MD5 authentication. Currently, there is no authentication. If there was simple text authentication, there would be any monitoring program could follow the authentication. We can see the monitoring, and then there is a default timing set here. Let's just go further with our script. Layer Zinnia is launched here. This is the king of layer 2 audits. So anything you need on layer 2 is incorporated, is entailed here. It shows you that under the HSRP tag, it found the packages. We want to become active routers. Therefore, you have to write the IP address in a reverse order for some sort of perverse attitude. And then if we start the attack, then in the background, we can see that a coup message went out with a priority of 255 and told the active device that it wanted to become the active device with IP11. Now the active device responded, okay, let's discuss that. Again, this has been repeated, so we want to be the active device. And then device number 1 accepted to go on standby. This was a simple attack. There is nothing complicated here. We were just pushing the keys on the keyboard. And then we can see that it took 10 seconds for device number 1 to regain its active status. We can see that they are still just discussing, and then now it is active. So it took 10 seconds to take over the active status, or to take back the active status. Let's go further with our script. This here is another attack which I'm going to be used from this point on. This is a device called... What I did here actually is I sent certain packages, and we can see that okay, so this is called Hyena. This is the name of this device. There was no coup message, so the active device had to resign because we just sent hellos, simple hellos. There was only just one signature for the HSRP, so probably... Now that we have the active role, my question is, who is now going to respond to packages coming from IP address 1.3? Because now we have the active status, and who is going to answer response coming to 1.3? Nobody. Nobody, folks, because we just obtain the active status, but we are not preoccupied of answering or responding to 1.3 or the other requests coming from that IP address. Now I have an interface. I will give my interface this IP address, and I will also use the standardized MAC address of the HSRP, and I'll try to answer, to respond. I need the network card. The Wireshark is then interrupted, but then I relaunch everything. And let's not forget that we only have 10 seconds not to lose the active, status, not even for a second. So again, I have another Wireshark, another attack, and here is our script. It would not be necessary. Anyway, I send an R ping, which is going to send packages on the network. We are then going to introduce ourselves to the members of the network, saying that our address is number 3 and the MAC address is this and that. If you look at it right now, then you can see that these ICMP packages are coming in to us, and we also get the answer. And if we look at the table, then you can see that we did nothing illegal because we had the same MAC address, so we didn't have to send out illegal RP packages. Now let's ping the destination. And we can see that the ICMP packages are coming in, but nothing happens to them. So they do not get past us. This is where the packages come from. They get into our server, but there is our computer, but nothing happens to them from that point on. So first of all, we switch on IP forwarding, and we set router number 1 as gateway. It no longer has the active status, but it's still a router, so it can route the internal packages. It's still doing its job, but the only difference is that it's now doing it with the IP address number 3 and not its original IP address. And then the user is just going to see that the communication is going on with server number 3. We ping it again, and we can see that all of the packages passed through us. There is only one problem, the ICMP redirect, which we send back to the victim. And here we tell him that IP address 34 is for testing purposes. Here is this gateway number 1, and this would be much better for you because I can only do the same thing as forwarding it. It's not good to send ICP redirecting because that again could trigger a response from the protection systems, and also if I accepted that, we would have been expelled from this half-obtained middleman status. So if we now look at it, what we see is that these are no longer going to be visible, these nasty packages. The whole thing is nice and blue, but there's still a problem. It's still the packages sent to destination, so we can only see what was sent from 34 to destination. The reason thereof is that there was an asymmetric routing. The package comes with 34 all the way along and the destination 34, and here that is not going to send us with destination 34 because it knows, this router knows that 34 is there and not us, so it's going to send it there. So there's asymmetric routing which could cause problems, and on the other hand it's only half of the packages that we see, which is not really beneficial if I wanted to monitor the traffic coming back from the destination. Again, we give another or instruction, a script, and interface not is switched on the network card of our device, and therefore the NAT interface NAT is going to send the address 34 on its own behalf. So what the router is going to see, that number 3 is here. It will see that the package went from our package, and therefore it's going to send it back to our package, and we will of course send it back to destination. So if we look at it again, if I switch this on, then this is going to go through, the traffic is going to go through, and we're in the middle. So this was HSRP, the most important objective, to show you this. I'm now going to stop the script. This is going to stop by itself, and we have a short script which is going to reconfigure the whole thing to VRRP, so that these should be not done manually, and it says config great and VRRP is going to be the next attack that we are going to use. Okay, now let's look at the protection, what sort of protection capabilities we have, how we could protect against that. Based on Cisco best practice, it would be MD5 authentication that we could determine. So an MD5 password actually as an authentication. And in that case, if FHR1 router would receive messages like someone wanted to take over the active role, but there is no appropriate authentication, then it would just log that we want the authentication, we want the IP address, and it also would inform that someone wanted to obtain the active status. And then what we see is that router number 1 sustains its active role and not willing to resign from that. Number 11 may also have an active role, and that could of course cause problems. Anyway, this would make the life of the attacker much more difficult. Solution number 2 was something I found on internet and on the forum. This is not a real protection or real solution. It's rather a very smart workaround. We take our active router, we set the maximum priority, and in order to prevent that this maximum priority would be pretended mimicked by someone, then we can set the IP address that we have there, and which is quite odd. It works very well. So you can see that 254 active router tries to attack number 11, but both of them are claiming to be active, and 254 is not giving over the active status. To the contrary, it also sends an ARP package saying that don't believe this guy, come to me. So it works well. Now, this is my favorite solution. Let's just write an ACL. ACL in Cisco's world, in the world of Linux IP tables, as now I learned at the workshop, is a firewall type of thing, and with a couple of ACLs we can ban all of the HSRP ports coming to HSRP packages coming to HSRP ports, with the exception of those that come from trustworthy sources. We can list it out, and it works very well. We have the permit rules, we had a match, and we can see that the non-appropriate addresses, coming from a non-appropriate source, will be rejected. Let's look at the VRRP protocol. The interesting thing is, and let's go through that, is that HSRP protocol is using was beyond the IP protocol, also using the transport layer. Now the VRRP stays within the IP protocol, IP protocol number 112, and it is only TTL 255 that it accepts. So if a package is not coming with a 255 TTL, then it would reject it. This is an interesting protective function, because this way it was solved not to get packages from other sources. We have a different MAC address, which does not really matter. Anyway, there is a standardized MAC address, and it's also the standby group that is identified here. So if it's group number 1, then it is going to be 1 and so forth. And the most important significant is that the most important difference is that you can calibrate it as a Cisco device. Like this is device number 2. Like let's say a number of devices, 2 or more, are in a standby group, and I take a virtual IP, and always the highest priority address would respond to the virtual IP. But there's also an opportunity saying that the master router, because here you have master and backup, so everyone who's not a master is a backup. So that is the 1.1 IP address, and then it will say this is what I use as a virtual IP address, and this is what the backup routers are going to take over if anything happens to me. Now in this way we can take the role from him, but we'll have the same IP address, and we also want to communicate with that IP address. And this IP collision, if they're not working properly, then it is going to be very difficult to use it. I would like to show you a bit more in this presentation compared to previous presentations. I'm going to attack the information where there is a master router. So if the HSRP protocol was ping pong, that is table tennis, then this is just bouncing the ball with your feet, and as long as there is no problem, others are just standing aside and watching you do it. But when you fall or you drop the ball, then the next one is going to take your place, who is the highest priority router. The packet structure is a bit different. It is a version dependent. Let me just show you the version that was implemented by Cisco. We already have a newer version. I read both of the RFCs. It is almost the same with the exception of authentication. Now there's no authentication in simple text or identification. Now the authentication was taken out because they said, well, we can authenticate and then we do not give up our master role, but we cannot prevent anyone mimicking the master role and creating a conflict situation. Because if you have 2 master devices in the network, then that could really kill the network itself. There is no sophisticated package here. We have only one opportunity to send packets via VRRP packets, and we also have a very nice formula here, which is going to come with a time a bit over 3 seconds, because 3 packets will have to fall out, like in case of HSRP, so that someone else could get the priority. This is interesting because it's not from 0 to 253, but 1 to 254, and then if the master wants to resign from its role, then it can send the 0 priority, and this is something you can use in case of certain attacks. Again, this is something I didn't check thoroughly, but priority 255 can only go to the device which really has that IP address, which is used as a virtual IP address. So taking into account the previous example, if I have an IP address of 1, and this is my virtual IP address as well, then my priority is going to be 255. Now, thank you very much. And the VRRP demo is going to aim at showing you a situation where the master clones the IP and the virtual IP, and we will see that this is going to be a bit more difficult. What you can see here is that there is no transport layer. There's an internet message control protocol, and this is not the right one I'm looking at. Yes, this is the protocol I was looking at. I was looking for priority 255. If I click on it, then you don't really see it. So it's priority 255. This is something. This is known by the Wireshark, based on expert info. There's no authentication here. Maybe it wouldn't change a lot if there was a simple text authentication, and also the virtual IP address, which is important at this stage. And before doing anything else, let's just look at this, whether we can see the right tool and device. We just start to think. And we can see that it recovers and the whole thing starts functioning. What matters is that they see the destination. If we look at the ARP table, then we can see that device number 1 took over the standardized MAC address, and we try to make the victims believe that we were them. Let's look at the script. We were not really very fine cut here, but we are now keeping a low profile in the network. We have an IP address of 11. This is important because the tool what we are going to use should be functioning. So let's launch it. This is a tool written in Python, and if we said that here Xenia is the winning application, then we can see that this can be used for routing protocol, and it is also possible to authenticate. Now this is RTR0 interface. Let's just set it. VRRP comes up. The software shows that it found interesting packets or packages, data packages, and data packets. Sorry. And let's say we want to take the IP address. And let's just introduce ourselves that we are the owners of IP address number 1, and let's throw there our MAC address and let's see what happens. Get IP. Scroll back a little bit. We just sent in a package with the priority 255, and we also sent the free VRRP package saying that your address belongs to here, and this is quite valid. But the situation is not that easy, because IP address number 1, despite the fact that we try to obtain it or take it away, it is still in use, because this is also the original IP address of our device number 1, and that is going to answer as well. It will always have the last word, and he also tells us that this is the case, saying that they're here. And if we look at our device, where it is right now, then we can see that he was the winner. So device number 1 rewrote the MAC address to a MAC address that is not supposed to be there, but we can't do anything here, because no matter how many RPs we send in, ARP packages, they are going to have the priority. Now, if there were 200 to send in, they will give it up after a while, but this would be very brutal, so that's not really gentlemanlike. Let's find out something else. First of all, let's assume the IP address. Let's put it into a sub interface, and then let's say that we are sending an introductory ARP packet to the victim, only to the device from which we would like to rechannel the traffic. And then let's do this, and then it's not going to well, we are now sending out the ARP packet, and we will ping the router in order to make everything work fine. We are using Hyena here as well. If we look at the coupling, we can see that it's the same MAC address that was here originally. So we didn't send any packet that would be a characteristic of ARP, and any of the devices would hook on that. So if you look at the small window, we see that we have restored the original situation. The client doesn't see that it is chatting with us.
Megpingeljük a default gateway-t, ami ilyen esetben 1-es, ugye? És látszik, hogy gyönyörű szépen bejönnek hozzánk ezek a csomagok.
We can see how these packages are coming to us.
Megpingetjük a destination-t. Tök jó, ugyanaz van, mint az előbb, ugyanúgy nem válaszol. Innentől kezdve igazából...
Here, basically there's not much we have to do. It's the same thing like with the HSRP.
Ezek ismerősen csengenek.
Of course, all these are familiar. We actually set the default gateway. With the default gateway, there's a bit of a difference. It's not the one that we'll use, but the two. It would really look stupid. Is IP address 1 will be sending packages to IP address 1, so we'll just stick with 2. And the packages will be going up and down wonderfully. I'll still show you how they do it. Wonderfully across.
ICMP redirect most pont nincsen, bármikor lehetne, de azért ezeket illik szépen kikapcsolni, ugyanúgy, mint ahogy az előbb is megtettük ezt, valamint ugyanúgy beállítjuk.
And we set precisely in the same way the NAT also, so that it should go across us, all the packages. And now if we look at it, not here, but here instead, we can see how packages and the whole data flow is going. This could be a telnet. I'll show you a telnet, for example.
Bekéri a jelszót, beírom a jelszót. Persze minden billentyűleütést külön vitt át, úgyhogy egyesével, hogyha valaki akarja, akkor ki hámozhatja azt a kőkemény 4 karaktert.
If anybody wants to, they can really see the characters, you can see everything. Basically, the whole man-in-the-middle story, and that's the bottom line, is that the virtual IP address is the same like the IP address of the master. And we've managed to update the whole network by not sending any illegal packets. And in the end, we really had all data flow through us. So let us the VRRP protection possibilities, MD5 authentication in the Cisco world, because for Linux there's very interesting solutions, but in the world of Cisco, MD5 is fantastic, you can really use it well. Of course, the attacker is going to have a tough job. You can see the Wireshark output, the 11 and the 1 fighting against one another, both of them declaring to be the master. However, it is going to give up to device 1. We've already seen that it is a protection vis-a-vis HSRP if the master IP is identical to the virtual IP, because then in that case, he will always update the ARP packages. It would have to be very, very aggressive. That I think is not an advantage. Just purely to be able to take over the active role by attacking this way. So I think this in itself is a good protection. And of course, we can also protect them with an access control list. Of course, the difference being is that in the world of HSRP, we said UDP 1985 port. Here it's an IP protocol, it's 112. It's basically IP 112 protocol. In the end, it is the same. You see the permits, the denies, the matches. So the final result is the same. This really shows how HRP poisoning versus FHR hacking. If you look at the static ARPs that you're using in ARP poisoning while you cannot, that is a true protection. If you're using ARPWatch, it doesn't really protect the network, but it's going to be writing emails to the sysadmins who are not going to be very happy to wake up at 3 o'clock in the morning for this. Some operating system security, yeah, there are some built-in protections for ARP poisonings. It's very, in certain cases, that they will accept ARP updates, IDS, IPS. Again, the same story, there's a lot of signatures. And the .1x, which again is physical access protection. So it's not really port. Well, anyway, it's a certification-based access to ports. Naturally, of course, it will provide a solution for everything. So if the attacker doesn't have access to the network that he wishes to attack, then he cannot be successful. We can see in static ARP OS security, these are not a solution for FHR. are hacking because we didn't send out not one single illegal packet. So for any IPSS, I'd be happy to attack the first hop redundancy because the fidelity rate is so low. It is such a signature is so lowly reliable that they will not find it. And of course, fundamentally, I did not want to basically discourage you from redundancy. It is good. Redundancy is good. If it wasn't for redundancy, those operations would have a lot of much more sleepless nights. In a given case, they would spend the afternoon next to a router. This is where you can contact me. Please contact me personally. I'd prefer that. I'm here today, tomorrow. Bring beer and let us talk. Really, of course, I can answer emails, but the topic, the complexity of the topic, perhaps allows much more personal discussions.